6.5, applications of integers, and we already know that applications indicates that we're going to be dealing with word problems on these, and integers means we're going to be looking at not only positive numbers but negatives. I don't think we're going to see any decimals or fractions yet, but definitely some negatives, okay? So translating and solving, starting with multiplication and division. So starting with multiplication, actually, let's look at a product, right? So these are usually some words that we look for when we're looking to translate and solve these. And yeah, for the homework, you're going to have to translate these, all these problems. And if you're ever dealing with negatives in the homework, as far as I could see, it wanted all negative numbers in parentheses. So we're going to have to remember that when we go through these problems so that we know how to get 100% on the assignment as well. But a product is the answer to a multiplication problem. Of course, times is kind of a different way to say multiply. It's used very often. If you see this word, you'd know that you're dealing with multiplication. If you ever see doubled, you'd multiply by 2, tripled, multiplied by 3. We don't see quadruple very often or anything beyond that, but doubled is kind of a common word to see. If you see the word of, again, generally with direct translations, it's multiplication, or again multiplied by. Again, that's a pretty direct translation right there. Now, order with multiplication doesn't matter, right? So even if you had the two numbers mixed up that they should give us, they should only be giving us two numbers at this time. If you mix them up, then it wouldn't matter if you're dealing with multiplication. But once you start looking at division, then it does matter. Order does matter. Remember, in a division problem, right, whatever you divide by, the first number is usually the number that you start with, and then the second number is maybe how many groups you're dividing that value by. And so you'll see this as well. Sometimes it'll say equal parts. It seemed like it was a common one in this particular lesson. Or per. Sometimes it's shown as a rate, right? You're comparing two things, like miles per hour or dollars per hour, something like that. See that often. A quotient is the answer to a division problem, so that would indicate we're using division. Of course, if it says divided by, now this is a direct statement, divided by. Divided into is not a direct statement. We can see this example down here. 2 divided into 6 means 6 divided by 2. And 6 divided by 2 means, well, this would translate as 6 divided by 2. But 2 divided into 6 is another way to demonstrate long division. So 2 divided into 6. That's another way to say that with long division. But generally, when we think about translating these into division, we would be looking at something like this. Sometimes as well, we would use a fraction, right? So per would indicate some type of rate, like miles per hour, something like this. So if you ever see a rate like this, and I know we haven't covered rates, but it's something you may have some familiarity with. Miles per hour or something like this, or dollars per hour. That's a pretty common one as well. So you'd have dollars per hour, and when you see a rate or a comparison of two different values like this or quantities, then you should know that you're dealing with some form of division on those ones. So as extensive as that was, we may not see a lot of that terminology in here, but we should see some of it at least. So the first part here, it says to translate, and then we're going to solve these, right? So on the homework, it's two parts as well. You're going to have two boxes to fill. The first one is for the translation. The second one is for the solution. So and remember, when you're doing these types of problems, these are word problems. We've said this many times before, and really I can't overemphasize it because sometimes students get the idea that, well, I mean, this is new to me, so I should only have to read it once and do the problem. Well, that's true if you have enough experience, but where we're just learning this stuff, remember that you may have to read these problems 2 or 3 times to really understand not only what operation you're dealing with, but sometimes where the numbers go, especially when you're dealing with subtraction or division. So you have to pay attention to the words, and sometimes you have to maybe read that slowly. That may take you longer just to read the problem several times than it takes to actually solve it. For some of you, that may be backwards, and that's okay too. So this one, right? 9 friends have a debt totaling negative $99. If they share the debt equally, keywords in there, what number represents the change in dollars for each friend? So remember right here, it says that they're sharing the debt equally right there, right? And so again, you have to go through this several times. We can kind of speed through it just almost based on my experience, but again, on your own, you may have to go through these several times. Sharing the debt equally indicates that we're going to be splitting something up, well, equally. So that would indicate that we are going to be using division on this problem. Well, what are we dividing by? Remember on that last slide how we said, remember you start, the first number here is the number that you start with. The second number is how many groups you're dividing it into or splitting it up with, or I guess in this case, sharing the value. So what number are we starting? We're starting with 9 friends, or are we starting with $99? Well, you're going to start with the $99 and divide it with the 9 friends. So that $99, of course, it's debt. Different color here. The $99 is owed. It's a debt, so it is a negative 99. And don't take that as a double negative kind of thing where it's hey, it's negative $99 in debt. That means it's $99 that we have. Don't make that more complicated than it needs to be. So we're just going to write this as negative 99. That's the value we're starting with. It's the value that we're distributing. And how many groups are we distributing it amongst? 9. So we are going to divide this by 9. And again, order will matter. Negative 99 divided by, negative $99 divided by 9 people. Now remember on the assignment, it's going to want these negative values in parentheses, so we got to make sure we put this negative 99 in parentheses. If you're doing this by hand, it wouldn't really matter to me, but on the homework, it will want this negative 99 in parentheses. If you don't use the parentheses on the homework, I think it will mark it wrong on those. So this is our first answer right here, this part right here. Now I'm gonna box it in later because I'm gonna need it. We are looking at division here, and we do need the answer to this. Since we're dividing, remember, we only have 2 values here. You could say there's an odd number of negatives, so you know your answer is negative. But if not, you should look at this as, well, the 99 is negative, the 9 is positive. They're opposites, so you should know that your answer will be a negative. Well, from that point, now that we know the sign of the answer, all we're going to do is take the 2 values and divide them. But we'll divide them without the signs on this. So we're going to take the 99, and let's go and divide that by 9. Now I'm going to use long division on this one. Although, yeah, we kind of do expect you to have this memorized at this point. I'm still going to show the long division at least on this one. So let's say 9 goes into 9 once. 9 times 1 is 9. Subtract that 0 out. Drop this 9. 9 goes into that 9. See if I can do a better 9. There we go. 1. So subtracting that 9 out gives us the remainder 0. But our quotient there is 11. And applying the negative sign that we saw before gives us a final answer of negative 11. But remember, there's a word problem, so we should label our answer. It's not just negative 11, it's negative $11. Right, so each of these friends would, if they're paying the debt or sharing the debt equally, would pay $11 of the debt. So 2 parts to this answer, right? We had this first part right here, which is the translation, and then the second part here, which was the answer at negative $11. I don't think you have to label the answers on the assignment. If it wants you to, then it should specify, but again, when we're doing this by hand, we always label it. George bikes to school each day. If he can travel 32 miles in 8 hours, how fast does he travel in 1 hour? So we have a comparison here, right? We're looking at he's biking to school each day. This isn't so necessary for the problem. It doesn't really help us other than we know the name of the person and we're using a bike, right? He can travel 32 miles in 8 hours. Okay, that's important information right there. In fact, that is a rate. Now, in this problem, it used the word in. You could, if you wanted to, replace that with the word per, right? 32 miles per 8 hours. So when it says how fast does he travel in 1 hour, we're looking for a simplified form of that rate, 32 miles per hour. And so when I do these types of problems, I don't usually use it with straight division like most people would. I would use a fraction. Just like I said, usually when we see comparisons between 2 quantities like this, when it uses the word in or per, then we would want to show this as a fraction. And I would just say, well, the first value is 32 miles right there, so that would be my numerator. It doesn't matter if you put this in the numerator or denominator yet. What is important is where we put the labels, right? So the 32 miles needs to be, I'm going to put it in the numerator. The 8 hours I'm going to put into the denominator. Now, here's what I mean by the labels, okay? I'm going to form an equivalent fraction to this one, which really just means that I'm scaling this fraction down until we find the speed or the distance for 1 hour. And we see hours in the denominator, right, for the 8 hours. So I have to put my hours here in the denominator as well. Well, this is just scaling the fraction. I just need to solve for this unknown value. So I'd say, well, I'm scaling the 8 down into a 1 in the denominator. And again, it wouldn't matter if you put this in the numerator because you'll still get the same speed. You just may have to, I guess, change the label on this. But 8, if I'm going to simplify it down into a 1, with fractions, remember, you can only scale up or down with either multiplication would be up, down would be using division. So I know I need to use division on this one. I'm going to take the 8 hours, I'm going to divide it by, well, what do I got to divide 8 by to make it 1? 8. But since we are scaling the fraction, I'm not changing the value, I'm only changing the way that it looks. If I do it to the denominator, I must do it to the numerator as well. So I'm going to divide the 32 by 8. That's a value we should know as 4. So 32 divided by 8 is 4. Just make sure you put the label on there, 4 miles. If you wanted to, of course, on the assignment, you just make this 4. And I don't actually see anything that would be negative on this one. So this is kind of taking us back. Like if you're doing this by hand, you could label this as 4 mph, miles per hour, right there. But our first part of this, the translation there, would be the 32 miles divided by 8 hours, and you may have to use the division sign on the assignment. And then the answer for this one, usually you just write in 4, but since I've written it as a fraction, I'm going to box in the whole thing just to specify that it is 4 miles per hour. Why did I not just say 4 miles? Because then it would change the question. And it may do this from time to time. It may say, well, how far did he travel in 1 hour? Then you'd scale this down, but your answer would just be the 4 miles. But since it asks for a speed, right, that's fast, how fast does he travel, that's speed, we need the full rate on this one, miles per hour. So as it turns out, yeah, I did it this way with the fractions. Yeah, some of you may have just looked at this and, pretty much from the beginning and said, well, I already know it's 32 divided by 8, and that's how I got 4 miles per hour. Okay, and of course that's perfect. You got the same answer. The method is solid, and so yeah, if you saw that in the beginning, feel free to do it. In fact, there's technically, I don't know, at least 4 other ways I can think of to do this problem, but this is kind of the way I set it up in my mind. So if you're like, I don't like the way you set it up, I did it a different way, but I still got the same answer. That's the key thing, is that you get the same answer, not necessarily the technique, right? It's about getting the same answer. All right, we'll translate and solve this one. The temperature in Scottsdale changed by negative 77 degrees in 7 days. If the temperature changed by the same amount each day, how was the change in temperature per day? Sorry, what was the change in temperature per day? Well, this one we're looking at another rate, right? Negative 77 degrees in 7 days. So again, you could say per 7 days. I don't know if that really helps, but if the temperature changed by the same amount, this same amount thing right here means that we're dividing it equally, and I'm using that word specifically. Not only does the word in indicate that we should be using division right here, because you could replace it with the word per, but that you're dividing it by the same amount each day should also indicate that we are using division on this one. Well, if we're using division, what value do we start with? Well, or what value are we going to be distributing evenly? In this case, it's at negative 77 degrees, right? Negative 77 degrees, we're going to take those 77 degrees that are negative and divide them amongst, well, 7 days. So this one is kind of like the debt one, right? Where the 9 friends are going to distribute it with the $99. They're going to all pay them equally. This is the kind of the same thing. Well, it kind of is exactly the same thing. Just now with temperature, right? And days. And yes, that 77 is negative, so again, make sure you put that in parentheses right there. You're going to need to make sure you do that if you want full credit on the assignment. But it's asking what was the change in temperature per day. So you could actually set this one up um, like I did that last one with the rate, right? So if I were to show this a little differently, you could say, well, I'm going to take those negative 77 degrees and divide it by 7, and you could label it, right? 77 degrees in 7 days. And you could use the fraction form of this to solve this. But we know since it said same amount each day, we're using division. So I'm just going to use this one here at the top, the one we originally had, which, again, by itself is an answer anyways. It's the translation. But then we got to actually solve it, right? So negative 77 divided by 7. Only one of these values is negative. 77 is negative, the 7 is positive. They're opposite signs, which means that the answer itself should also be negative. Well, then you got to do 77 divided by 7. And again, that's one of those basic division facts that we should know. That would be another 11. So we get another negative 11 on this, but label's different. What was the change in temperature? So that's just looking for the degrees on this one. Negative 11 degrees would be our second answer for this, and that would be the solution. So if, of course, you could write per day if you'd like to, but again, all you'd have to type in the box on the assignment for this one is negative 11. Since we're doing it by hand, we'll show the label for this one. Now, we are still going to translate and solve this thing, but it says Sarah hiked down a mountain for 3 hours. Each hour, her elevation decreased by 40 meters. Compute her change in elevation in meters relative to her starting point. Now, there's a couple different ways to translate this, but on the assignment, just so you understand, is it's going to want it wants you to use a specific operation. Now, it will specify what operation it wants you to use, so don't worry about that. But just so you understand, I'm using these examples because on a quiz or a test, of course, it's not going to it may not specify what operation it wants to use. So I'm going to show a couple different options, but I'll specify which one it would want to use on this one. So we read the problem, and it sounds pretty good. With elevation type problems, I find that drawing diagrams of what happens may be helpful. So I'm going to start out with this one. Okay, so you're going to hike down this mountain, right? So this is kind of where Sarah starts at, is what I'm going to say right here, this black line. So this is her starting point. I don't really care that she's biking necessarily, or hiking rather, but I just want to know that this is my starting point. Okay. Now this is a diagram, and I'm not going to draw mountains, although if I had a nice afro and I had some happy trees, I would for you. But you don't want to see. I think that my drawings make people more angry because of the sloppiness of it all. But in any case, you're going to go down the mountain for 3 hours, right? So we know she's going to do this for 3 hours. And I'm going to say each of these red lines here, that's 1 hour right there, right? Now she's going to do this 3 different times. So there's 1 hour, there's another hour, and then there's another hour. And then right at the end of this would be, I guess, the end of the hike. So this is where she's going to end. Now, for me as well, I'm going to say that she's going to start at 0. Whatever it is, the top of the mountain is starting at 0, so she's going downwards, right? Down the mountain. That's a key word, because since we're going, or she's going down the mountain, that indicates that each hour she's going to go down, well, it says 40 meters, right? So not only am I going to put 40, but negative 40 on this one, right? That's down 40 meters. But then the next hour, it's another down 40 meters. And then that third hour as well, down another 40 meters. Now, what you could do on this one is say, well, I'm just going to add these negative values and find my answer. And your answer would be correct, by the way, if you did it that way. But what it really wants on this one is for us to use multiplication, because it's 3 groups of negative 40, right? It's pretty much saying that you have the 3 hours, that's the 3 groups of, well, the distance each hour, negative 40. Just remember, since it's a negative 40, you're going to want to put that in parentheses. I mean, you're going to have to show the multiplication either way. so that it's not, the negative is not confused with the minus sign. But showing it like this is okay. If you want to put the multiplication in between it, it should be okay as well. But you don't necessarily need the multiplication symbol, but you're welcome to put it there, okay? So this is the expression that they would want on the assignment. This is part of the multiplication section. And the last thing we got to do is actually solve this thing. And remember, when solving with multiplication or division, we either count how many negatives there are or to see if the signs match or are opposite of each other. So the 3 is positive, the 40 is negative. They're opposite, so I would know that my answer is a negative first of all. Or if I was counting negatives, I'd say 1 negative. Here in the multiplication, 1 is odd, so my answer is negative. That's okay too. After that, we're just multiplying the values, but just without the signs, right? 40 times 3, so 3 times 0 is 0, 3 times 4 is 12, we get 120. Just don't forget to apply the negative symbol onto that, negative 120. Last thing I would want to do this, of course, is just label it, and it says compute her change in elevation in meters. I'll just put an M on that, and we'll box that in. We'll call that our answer right there. So, 2 different parts of this, the translation and the solution. But there you go. Now, I will mention this too, is let's say that by chance you thought this was a division problem, right? Or even multiplication or addition or subtraction, okay? Let's say that you, for some reason, came up with the wrong operation. If you came up with the wrong operation, hopefully it would kind of make sense that that would not be the correct answer. Like if you did, let's say you divided these directly, you're going to end up with a pretty ugly decimal, and we haven't even gone over decimals yet. Or even if you did 40 divided by 3, you could say, well, there's a remainder, but compute her change in elevation, it'd be just a little over 10, I guess 13-ish meters. And well, she's going 40 meters in 1 hour. So again, just with some analysis and rereading the problem, you should be able to tell that your answer's off. Okay. Same with addition or subtraction. If you added these 2 numbers, 43 or 37. Again, neither of those make sense because her change in elevation is 40 meters every hour. So make sure you pay attention to that. Make sure you double check that it does make sense to you in the context of the problem, because if it doesn't, then you may want to try a different operation. Or I guess if you're using subtraction or division, you may have to change the order of things. That may help as well. Translate and solve again. Leslie bought coffee 2 days this month and charged it to her checking account. She spent $9 each time she visited the store. Determine the change in dollars in her checking account. Now, to me, this one isn't so specific. Like, well, how many times did she go to the coffee shop in the 2 days? It doesn't say, which means that we just get to assume that she bought coffee 2 days this month, meaning that she went 1 time per day. So for those of you that maybe go to a coffee shop more than 1 time per day, you're like, well, that seems unreasonable, but well, this problem may seem unreasonable to you, but that's what we're going to do, okay? Because we don't want to make this more complicated than it needs to be. So on this one, she's going to it 2 days this month, so she's going to it 2 times, but every time she goes, you're going to spend $9 at the store, okay? That would indicate that we're looking at multiplication, because remember, it's like saying you got 2 groups of the $9 spent, and that's crucial on there, the spending part of that, okay? So since it's 2 groups of spent $9, indicates that we are using multiplication. So there's our multiplication symbol. For me, I would write this as 2 groups of not just 9, but since it was $9 spent, that's a crucial word right there. We're looking at negative 9 on this. And it should specify that with the last part, determine the change in dollars in her checking account, right? So the negative should tell us the change in dollars in her checking account as well. Just remember, once again, since we are looking at the 9 being negative, you're going to want to put that in parentheses. Now, again, order shouldn't matter with multiplication, so I believe on the homework, even though you'll need parentheses around the negative 9, if you typed it in as parentheses negative 9, close parentheses times 2, I believe it will give you full credit on those. Excuse me. Now, we got positive 2 times negative 9, and that will be the first part of the answer. That's the translation. But we also need to figure out the sign of the answer because we got one positive, one negative, right? And since they are opposite signs, you would know that the answer is right away going to be negative. Or, again, if you're counting negatives, there's one negative, one is odd, which makes the answer a negative. And we only count the negatives when it comes to multiplication or division, right? Um, but after this, all we got to do is multiply the two numbers, which is just 2 times 9, and we should know that 2 times 9 is 18. So not only is the answer 18, but negative 18, and then we need a label for this answer. Yeah, it was determine the change in dollars right there, dollars. So we'll label it in dollars as well. Negative 18 bucks. There's two parts to our answer right there. We did it. All right, translating and solving with addition and subtraction. Again, by the way, these solving the ones that we saw with multiplication, adding and subtracting. Those are things we've seen before. That we've seen these slides before. So with addition, of course, sum would be the answer to an addition problem. Plus is just a different word for adding, added to, more than, increased by. And yeah, order for addition does not matter. So when you see the two values that they give us, of course, it doesn't matter which order you put them in. But with subtraction, if you see these words, the difference, of course, is the answer to a subtraction problem. So if you see it, you know that you're dealing with subtraction. Minus is, again, it's kind of a different word for subtract. Or being decreased, something being decreased would indicate subtraction. Now, these words that I just went over, these phrases that I just went over are, they're all direct statements, okay? If you see these other two, subtracted from or less than, these are not direct, which means that the order is actually switched, which is what it's showing down here, like specifically with less than. 5 less than 7 means 7 minus 5, okay? And generally speaking with students, if we think about this in terms of money, right? $5 less than $7. Most of you do that pretty quick in your head. Okay, it's $2. Well, how'd you do it? Because it's 7 minus 5. Well, if that helps you to think about this in a better way, then do it, okay? But 5 minus 7 is direct. 5, you'd say 5, subtract 7, and then you'd perform that operation right there, which we'll see some examples like that. Okay, subtracted from works the same way. So 5 subtracted from 7 would indicate that you'd start with 7, and then from that 7 you would subtract the 5. So hopefully that kind of makes sense why the order is switched with these two particular subtraction phrases right there. Equals, of course, we shouldn't see this too much with the equals thing, but we may see in the future. So equals is, yield, results in same as, all would be an equal sign when we translate that into a mathematical statement. Translate and solve this one. Don had $8 in his checking account and wrote a check for $11. And what it's going to ask is kind of what's the net value of his checking account? How much does he have left in his checking account? Something like this after writing the check. Okay, so here's what we know. We know he has $8 in his checking account, but then after he has the $8 in the account, then he writes a check for $11. Okay. Now, that's a check that was written for $11. So the 11 actually would be considered negative on this one. And then the $8 we start with, well, it's positive 8. He had positive $8 in his account. What we're really doing on this one is adding that negative 11. And so since the 11 is negative, we would want to put that into parentheses, okay? So keep that in mind. Now, also keep in mind that this is part of the addition section of the homework. So if you put 8 minus 11, while it will give you the correct answer, it's not the expression that it's looking for. So we would want on this one 8 plus negative 11. But the 11, again, that's negative. It needs to be in parentheses. So that's the first part of our answer. That's the translation. And to solve this one, remember we're adding now, so we still have to look at the signs of the values. We want to determine the sign of the answer first, and the 8's positive, the negative is 11, so the 11 is negative. So we know that we're dealing with opposite signs on this. So whichever value is bigger, that sign of that value will be the sign of the answer. So 8's positive, 11's negative. 11's bigger, and so the final answer will also be negative. Now, since the signs are opposite, you always take the bigger of the two values, which in this case is 11, and subtract the smaller of the two values, which in this case is 8, and 11 minus 8 is 3. So again, the final answer here not only is the 3 there at the bottom, but it's negative 3 in the end. Not just negative 3, but it's we want to label on that one in dollars. So there's, again, a two-part answer, the translation and the solution. There we go. So we're just constantly applying all the same rules for operating with negatives as we've seen before. But we have to figure out what operation we're using first. So Malala's pool was filled 10 inches below the top of the pool. She drained the pool 5 inches. So the first thing we want is a translation on this, and they should specify something to the effect of that we want to know the water level in relation to the top of the pool, okay? So again, I'm going to kind of draw a picture because we are looking at height on this one, and height is generally very nice to show with a diagram like this. So this line right here would be the top of the pool, right there. I can write that bigger. Hopefully that helps. There's the top of the pool, okay? And I'm just going to put top so I know it's the top, okay? Well, to start out with, the pool is going to be 10 inches below the top, right? So this is where it starts at 10 inches below. So I'll put a little arrow there as well. So that's where the pool starts. But then, in addition to that, it says, hey, we're going to drain the pool another 5 inches, okay? So not only is it 10 inches below the top of the pool, but we need to go down another 5 inches right there. And yeah, that's not proportional. I don't really care that it is, but we're just going to go down another 5 inches. Okay. So let's write the expression for this. Okay. So the 10 inches, that's where we started, right? So no matter what operation we're using, I'm just going to put the 10 here. And well, it says that she drained the pool another 5 inches. So for me, I would say that this is actually a subtraction problem on this one, because draining would indicate some form of subtraction on this, at least for me. Okay. Well, how much was drained? Well, 5 inches was. So I'd have 10 minus 5 right here. Yeah, I know that's incorrect specifically because of the diagram that was drawn right there. So, of course, if I did 10 minus 5, I'd have just 5. But I know that can't be the case. So, so here we go. This is where I made a mistake here. The minus 5 is okay. It's the 10 that I went wrong on right here, okay? It's the 10 is 10 inches below the top of the pool, so the 10 should actually be negative. So there we go. I'm going to put the negative right there. And again, since we are operating with the negative, I'm going to put parentheses around the value that is negative. So this becomes negative 10 minus 5. And remember, when operating with negatives this way, whether you're using addition or subtraction, we usually force the operation to be addition, right? Now that means we can use the keep change thing, right? So the negative 10, we're going to keep that negative 10, but we're going to change the operation. Remember that we're going to change the operation into addition, and then the 5 also gets changed into a negative. Now, just so we understand, this is the translation. That's the translation that it would want on the assignment. But when we're working with it, this is usually the value that we would want. Now, if by chance a problem like this was in the addition section, of course this would be the translation that we would use, but I believe it's in the subtraction section. So now we got negative 10 plus negative 5, and now the answers, or the two values match, right? They're both negative, which means that the answer itself should also be negative. So I'll put the negative sign as part of my answer. And when the signs match, of course, all we're going to do is take the two values, 10 and 5, but without the signs you're going to add them since they have the same value. 10 plus 5 is 15. So the final answer here is negative 15. And it looks like our label here should be in inches. This would be negative 15 inches. Now you can say it's just negative 15 inches. Of course, that's the number you type into the box for the answer in the assignment, negative 15. But as an interpretation, we would say that it's 15 inches below the top of the pool, and that would also work if you were typing this in by hand or something like that. But since we're just filling in the boxes for the assignment, that's as far as we would need to go on that one. Translate and solve. Carlos lowers the temperature of his freezer by 6 degrees. It was originally set to negative 11 degrees Celsius. Now the Celsius thing doesn't matter. I mean, we can put that in the label if we want, but we're looking more at the degrees. We'll get to assume that the 6 degrees was also in Celsius, so no need for changing the temperature from Fahrenheit to Celsius, nothing like that, okay? But Carlos lowers the temperature of his freezer by 6 degrees. So remember, reading these a couple times may be helpful. So we see that it's 6 degrees, that's how much it's being lowered by, but it was originally set to negative 11 degrees. Now over here for me, I would say that the lowers part would indicate that we're dealing with subtraction, right? But remember, order does matter with subtraction, so I can't just kind of blindly write in here 6 minus negative 11, nothing like that, okay? We cannot just make a quick assumption like that. Always make sure that you're kind of analyzing the words here to make sure that the values go where they should. So you always take the value you start with, and then whatever you're taking away from it would be the second value, and the value that we start with on this one is the negative 11 right there, right? Because that's what it was originally set to, which indicates that that is a starting value right there. So we're going to start with the negative 11. Since it's negative, I'll put that in parentheses. And we're going to lower this by the 6 degrees. The lowering of the temperature is the subtraction sign. And then the 6 degrees, yeah, we'll just keep that as a positive right there. So this is the interpretation or the translation, which, by the way, again, it goes in the first box. Negative 11 minus 6. Now, again, we don't usually subtract with these negatives. We usually change the operation into addition, right? So that's a keep, change situation. Keep the negative 11 in parentheses. Change the operation into, now, addition. And then change the 6 from positive 6 into negative 6. So I'm going to put that in parentheses, although it wouldn't be necessary because this is our first translation right there. So I got negative 11 plus negative 6, and I want the answer to that value. So since both of the values are negative, I would know that I'm dealing with a negative. So my answer should be a negative. And yeah, from there, just take the two values. Since they're the same sign, we're going to take the two values and add them together. Just applying the negative that we know the answer is. 11 plus 6, there's a 7, drop the 1, 17. Negative 17. You can put degrees Celsius if you'd like. Whatever you want, but that would be our answer for the second part. That is the solution. Now remember, the order on this one was a little different, right? They gave us the values kind of out of order with direct translation because it was the temperature was being lowered by 6 degrees. So you'd have to ask yourself, well, what temperature was started at? It was at the original setting. We'll translate and solve this one. Kayla camped at negative 9 miles relative to sea level. She then hiked 3 miles upwards. What is her current altitude relative to sea level? You know, let's go ahead and take a minute. Take 1 minute. See if you can solve this one, then we'll go over it together, all right? So I'm gonna draw a diagram on this one again, just because it's kind of an elevation one, up and down. And for me, that's when the diagrams help the most, it seems like. So it says, Kayla camped at negative 9 miles relative to sea level. So right here, I'm going to say that this line right here represents sea level, but not just sea level, but it would also indicate a value of 0 or an elevation of 0 right there. Sea level. Oh yeah, I spelled that right. There's 0, particularly 0 miles, because we're just dealing with miles on this one. But she's gonna camp at negative 9 miles relative to sea level. So from sea level, since it's negative 9, would have to go down 9 miles at this point, right? And this would indicate where she camped. Negative 9 miles. Okay? So this is where she's going to start at. And just at this point, by the way, we should know that we're going to start at the negative 9. I mean that's the first value that we're going to have, whatever operation we're going to be using, okay? Whether it's multiplication, I mean, if it's division, we'll figure that out. Maybe it needs to be second, but we'll see, okay? Because then it says she then hiked 3 miles upward. So there's the 9 miles. We see that she, from that camping site, she's going to hike upwards 3 miles. So from that 9 miles, we're going to need to go up another 3 miles. Again, this is not proportional. She's got to go up 3 miles from the hike, right? So that puts her right here, which, by the way, for us is really just kind of the end of this problem. And what we want to do is figure out the elevation on this one, right? Well, now, since she went upwards, by the way, she hiked upwards, that would indicate that we're using addition. Well, she hiked upwards 3 miles. So that's a negative 9 plus a positive 3. And that would be the translation for this problem, the mathematical translation. Well, since we have that, and that would go in our first box, what we need now is the answer to this one. Well, where did she end? So from 9 miles, she's going to go up 3. So, of course, you go back and say, well, that would be negative 8, negative 7, negative 6 if you like. So that would tell you that she ends at negative 7. Of course, miles. Or 7 miles below sea level. Or if you wanted to, you could have looked at it just kind of like with our rules for adding and subtracting integers. So you'd say, well, the 9's negative, the 3's positive. So they're opposite signs, and the 9's bigger, so we know the answer is negative, which we have. And so then from that point, you'd just do 9 minus 3. Oh, I said 7, didn't I? Dang it. That should be 6. Well, that's why we check. That's why it's good to do it 2 different ways. 6. I must have counted that one wrong. Let's see what I did. Negative 9, negative 8, negative 7, negative 6. There we go. So that would be negative 6 miles. Let's go and box in our answers then. There's the translation. There's the answer.